I was working on my Coilgun and suddenly, I heard like a loud bang kind of thing, and it was not my Coilgun. It was actually this magnet. It split in half, and then one half of it just flew out, and I don't know where it is. So, and then another one of them broke, and I don't know where that one is either. Both of the pieces have like gone flying. So I guess I'll have to work with 8 magnets plus one holder thingy for my batteries over there. So yeah, that'll make my Coilgun a little less effective, but that's about it. That's all that it's gonna really affect. It's not gonna affect much others. So yeah, that's it. Just a quick recap. This is my latest edition of the Coilgun. This is the Coilgun version 3. And it fires the projectile, this kind of projectile. Currently made of 8 magnets, since I lost 2 of them. There used to be 10. But anyways, try to find some replacements for them. It runs on 2 of these lithium-ion batteries, which I can recharge. Each of them has 4 volts of power stored in them. Currently, I mean, yeah, unless it discharges through this coil. That coil is large enough so that this thing can fit through, but it's not. It's small enough so that this thing can't like spin around and like mess things up. And so currently, what it does is it only fires until, for example, if we have the thing here, it goes all the way until it goes here, and then it stops powering this, and it's just causing. Only the inertia is powering this, the thing. In case you don't know, inertia is what makes a ball continue rolling once it's at the bottom of the hill. So it just wants to keep stuff like moving along. So an object in motion will stay in motion unless some force acts upon it. So yeah. So I feel like we can upgrade this. Maybe make it a more automatic. Make it more reliable, probably, and also maybe I should find some replacements for the 2 broken magnets, and also, yeah, and maybe connect the batteries in a different way to like maybe optimize the amperage, because it's really the amperage that matters, not the voltage of like the batteries. So, anyways. Because if you go in parallel, you actually have more amperage but less voltage. That doesn't really matter to me because I really want some amperage but not voltage. So yeah, and that's basically it. So I'm gonna go ahead and try and upgrade this, and yeah. Alright, so now that we are in here, I'm gonna show you what I plan to do for probably the next stage of my project. Let me quickly set up my battery and turn this off to like maybe like something like 15 volts or something. Okay, now that this has a 15-volt battery, you can see I'm in a circuit construction kit, AC simulation. By the way, you can try this at home. Just go to this link over here. I used it in a different video in my channel, so make sure to check that out as well. But anyways, so I'm gonna have a switch here to represent, well, a switch. This will be like the charging mechanism for all of my capacitors. So, we're gonna build an array of capacitors. So, I'm going to set all of these capacitance to the very minimum, which is in this simulation it's 0.5 farads. So I'm going to have a few of them, and I'm going to put them like really tightly packed. Now this simulation does allow for you to actually put things on top of each other. So I'm going to do that later once I connect these up. One more, and I'm going to go ahead and connect these up with the wires. There's a lot of clicking here. It's not a battery. And okay, now that we're done with the capacitor unit, I'm gonna move this entire thing, or at least try to. Don't know if I can. I'm gonna move these all on top of each other. No, I cannot move all of them at once. Can I select anything? No. Okay. I'm gonna move one of these capacitors. I don't know which one it is, but that doesn't really matter. Okay. So now when we go ahead and close this switch, it will charge it. Okay. Loading. Once it actually loads, it will let me see my task manager. Page unresponsive. Okay, it seems to be doing okay, so I'm gonna leave it alone for now. It's not doing very. Oh, there we go. So switch is closed, and now you can see the battery's on fire, which is not a very good sign. But in the real world, yes, the battery will be on fire because I just created a short circuit. Responsive, right? Yes. This is the slight problem with this one. It is a very kind of underdeveloped and will crash. Might crash it. Oh, there we go. I should. Is that it? Okay, so now you can see that it's slightly charged. Since I only put it at 15 volts, it's only this much. And then let me go ahead and move things. Anyways, let's go ahead and connect these to another circuit, which will be our output circuit. For the coil, I'm going to be using an inductor, and the switch will be me tapping the thingy on. So forgot to open that switch, and now you can see that the capacitor is discharging. Do this, but look at this. The inductor is kind of charging up these capacitors. Now, in order for you guys to see more clearly, what I'm going to do is I'm going to up the voltage. It's probably going to hurt my computer a lot. I mean, yeah. I'm going to move these out of the way so you can see, and I'm going to grab the current chart out of here. Put it here so that later, once this charges, and it's probably going to charge, I hope it's going to charge because okay, good. So now that these are charged, I'm going to open the switch and close this one, and you'll watch the current. Okay, you can see it starts going down, but then it stops going down. It starts going back up. And then it goes past going up, and then keeps going up. I'm gonna grab a voltage chart so you can see the difference. So we have voltage. Oh, okay. So you can see it's very similar. It's also kind of stopping and then going back up. In fact, these are perfectly out of step. When the voltage reaches 0, the current is at its highest, and therefore these are sine and cosine waves, either one. If you've learned trigonometry, then you know what sine and cosine are, but anyways. And as you can see, in an ideal situation, it will just oscillate forever. And in reality, it has some resistance. So if I open up this advanced tab, move this out of the way, my computer is lagging terribly. Turn up the wire resistivity a little bit. You can see that doesn't go to as high. This one doesn't go to as low. and then it will slowly, you know what, I'm just gonna turn the wire resistance to its highest. Now you can see that it is like dead, kind of. And voltage reaches 0 and then comes down a little bit. And like the whole thing just like stops. So in a real world, this is what probably would happen. It would just go ahead and try this thing, and then it would oscillate for like once or a few times, and then it will like stop because there's no more voltage or whatever. I'm gonna recharge the capacitors. Alright, actually, you know what? I'm gonna link many of these together just to like show you the effect of what it does. Probably going to be very bad, but okay, just 2. Now if we do this and then charge these up, they'll be very blue and very red. You can see so. And then if you do this, they'll be even bigger. This will cooperate. There we go. You can see that it's very big. It's already past the borders. Still past the borders. Still past the borders. But this basically shows how it's oscillating. You can create a very similar thing like this. Like a kind of whoa. All of the electrons are dislodging from the wires. Oh, that looks really strange. But anyways, you can create your own circuit like this in the simulation. So if you want to go ahead and experiment around with this kind of thing, you can do the same thing. But I still haven't talked about why I want to use this oscillation system. The reason is because, okay, let's say that it's going in, and then it reaches the center. You can see over there. This is where the center point is, and then it will go out. And then since the voltage is negative, the thing will be in a different. It will like run. I mean, the current is negative. The electromagnetic field will run in the opposite direction. So you can see if it's running in this direction currently. And then once it reaches up, and it's very laggy, yes. You can see that it would basically flip. See, now that it's positive, it would flip. So then what this does is once the projectile reaches the other side, since the southward is, so if north was pointing in this direction before, south will be pointing in this direction, and when in this direction, and when it's reaching here, the south, if we were to like, for example, if you have a magnet like this is north, this is south, you have another magnet, this is north, this is south, you push them together, they will repel. So then if you were to, same thing, if you were to have 2 south magnets, they would also repel. If you have 1 north, 1 south, they would like attract. This is the principle in which my Coilgun currently works. It just attracts and then it stops powering it. But what this will do, what this like oscillation thing will do, it will attract it. So the magnet, it will attract, and then once it's past, and once it's like here, like once they're like at each other, this one will flip, the electromagnet, and this will continue on, and because of its inertia, and then be pushed because it doesn't want to be over here, so it will be pushed out. So that will make it like even like more powerful. So yeah, but the thing is that it will need a lot of fine tuning because we'll need to time when the projectile reaches the center of the coil, and since the coil's inductance matters, if we have a higher inductance, the thing is too laggy to show. But if you have a higher inductance, it will oscillate. It will oscillate slower. If you have a smaller inductance, it will oscillate higher. So I need to time the oscillations correctly so that it will dip right when the thing reaches the center. So yeah, it's gonna be a lot of fine tuning. So yeah, I guess that's the end of the video. So I'll see you guys next time, and I'll figure out some way to get this less laggy maybe. I don't know if it's even possible, but yeah, that's it. So please like and subscribe, and I'll see you in the next video.